So sketching graphs, what I was saying the other day is when it comes to things like domain, range, that sort of stuff, if you know what the picture looks like, then it becomes a lot easier. So if you can visualize or sketch the graph, it's actually going to make questions easier. Some basic things, of course, with any type of graph, not only number plane graphs, even when you're doing graphs in other subjects as well. I mean, the rules are all the same. Your numbers on your axes should be evenly spaced. In other words, a consistent scale. We know y-intercept always occurs when x equals 0. And x-intercepts will always occur when y equals 0. The y-intercept, very easy to find. Just substituting 0. X-intercepts aren't necessarily easy to find. It depends on the function. You got a quadratic, easy. Linear function, even easier. Once you start getting up into cubics, as far as polynomials go, they can get a bit harder, unless they've already been factorised for us. So, if you can find the x-intercepts, you do. But if they're too tricky, we don't worry about it. Once you know your intercepts, if you know the basic shape of the curve, then it should be easy. Don't forget the most simplest idea of them all. If you're unsure, plot values. Now, whether or not that physically means draw up a table of values or just picking numbers and substituting in until you get a feel for what the shape is. I mean, it's still a very useful way of drawing graphs. Okay, the basic curves, we should have a pretty good idea of what they're going to look like. And of course, the most basic curve is a straight line. And the most basic straight line is y equals x. So it's our straight line, it's at 45 degrees. We then went on to learn about y equals mx plus b, where we can expand it out. So y is to the power of 1. X is to the power of 1. If for some insane reason you didn't realise it was a straight line, that's what you're looking for with a linear function. Both of those powers is to the power of 1. And that's how I guess you would recognise it. Then we go up a notch, our parabola, the most basic one, y equals x squared. To generalise that, we've got ax squared plus bx plus c. But this time we notice something. Yes, y is still to the power of 1. However, the highest power of x is now 2. That's an indicator we've got a parabola. When it comes to quadratics, it's easy to find x-intercepts. We just solve the quadratic and we've got the x-intercepts. The vertex, it's a symmetric shape, so it'll always be halfway between the x-intercepts, or the average of the x-intercepts. Okay, let's do one. X squared minus 4x plus 3. I'm going to do it via the completing the square method. And because when I've got it in the completing the square form, it says x minus 2 all squared minus 1, that tells me the vertex straight away. The 2 is grouped with the x, and then we've got minus 1. And we'll look at this idea about shifting curves in a couple of lessons. But that's basically saying to me, we're shifting horizontally 2, and we're shifting vertically 1. So my vertex is 2, negative 1 instead of 0, 0. The x-intercepts, well, seeing it's already been completed the square, I'll do it that way. I've got 1 of 3. Yeah, let's go get a rough sketch. I didn't even worry about the y-intercept on that one, but that, of course, would be 3. Some people would find the x-intercepts first, because the quadratic's easy to solve, and then average those out. You average 1 and 3, you get 2, and then just sub that in, and you find what the y value is of the vertex. Either way. Okay, the cubic. We have these sorts of cubics. The basic one, y equals x cubed. So that's if it's a perfect cube, it'll look something like that. Again, how would you recognise it? This time it gets real tricky. The highest power of the x is now 3, we notice. It becomes a cubic. If, as I say, it can be factorised to be a perfect cubed, it will have that sort of shape. Otherwise, it'll be one of the cubics which has 2 turning points. So something like that. And how do we know which type it is? And this is something you've probably never seen before. It's not in the notes, but if you want to write it down, you can. We use something that's similar to the quadratic formula. Underneath the square root of the quadratic formula, you have b squared minus 4ac. Yeah? For a cubic, we go b squared minus 3ac. And b squared minus 3ac, if it's greater than 0, it'll be one of these with 2 turning points. Okay? So b squared minus 3ac will be one of those. If it's equal to 0, it'll be like what we call a horizontal point of inflection. So that would go a lot flatter than my example here. And if it's less than 0, well, it'll still have this sort of shape, but it won't be horizontal, it'll be more at an angle when it twists through. Higher powers then. Even powers, they all have this U shape. Now only x squared is called a parabola, but the others still have a U shape. And what happens is, as that power gets bigger, it gets flatter at the base, steeper at the sides. And the odd ones, they all have what we call an inflecting shape, like that. But again, as the power gets bigger, flatter at the base, steeper at the sides. I guess the next type of shape is our hyperbola. And our basic one, y equals 1 on x. Could also be written as xy equals 1. So how do you recognise that one? If you see some sort of function where you notice one pronumeral's in the numerator and one's in the denominator, you've probably got some sort of hyperbolic function happening. Okay? Or the other way of just simply recognising it is if you see the x and y multiplied together. So if it's not in fraction form. So yeah, okay, good chance we've got some sort of hyperbolic function. Circles, x squared plus y squared is the radius squared, but this time we notice the powers are 2 on both of the x and the y. But not only are the powers the same, there we go, the coefficients are the same as well. If the coefficients were different, we wouldn't get a circle. We'd get, yeah, you get an ellipse or an oval if you prefer to call it an oval. Yep, you get an ellipse, provided they are the same sign. So both positive or both negative. If one was positive and one was negative, we wouldn't get an ellipse, we wouldn't get a circle. Anyone know what we get? You actually get a hyperbola. But it's a hyperbola that's rotated and the vertex is on the axes, either the x-axis or the y-axis. Exponential. There's our basic one, a to the power of x. How do you recognise it? Well, that's a bit easy. You notice the pronumerals in the power. Okay, you got some sort of exponential curve. That is, of course, to say, the one I've drawn is when the base is bigger than 1. If the base was less than 1, or in between 0 and 1, I should say, then it would be reflected the other way around. You don't have a negative base, you don't have a base of 1, and you don't have a base of 0. Okay? They're sort of meaningless graphs. So you're only going to get ones where the base is either in between 0 and 1, which would be the reflection of this one, or greater than roots. Now the top half of the circle is the positive square root. So basically you get the roots when you try to make y the subject of a circle. The bottom half would be the negative square root. And it's the same with, you could have a parabola on its side. So y squared equals x, but you make y the subject, and you'll end up with plus or minus the square root. Well, the positive square root will be the top half. The negative square root would be the bottom half. So basically, if you don't know, you see the equation and you see a square root sign in there, square both sides. It might become something familiar then. And you'll go, righto. So if I didn't know that was a half of a parabola, I'd square both sides and go, it's y squared equals x. And then I'd recognise that, okay, because it's the power of 2, so I know it's a parabola. This one's on its side, because it's y squared rather than x squared. And because it's positive square root, I just had top half. So I only want positive numbers. So circle, again, square both sides, and I can rearrange it and go, look, yes, I've got a circle. And there's the parabola one I was saying. So essentially, positive square root, top half, negative square root, bottom half.